Welcome to the deep dive. Today, we're going way back to the very beginning.
Oh, wow. The very beginning, huh?
Yeah, to tackle the mind-blowing story of how Earth was born.
Okay, yeah.
And get this, our main source is in Hindi.
Interesting. In
Yeah.
Hindi. Okay.
You might not expect it, but this source, it's packed with fascinating insights that'll take you on a journey through time and space.
All right, I'm ready. Take me away.
All right, so we're talking billions of years, folks.
Wow, that's a long time.
I know.
Yeah.
So are you ready to uncover the incredible chain of events that led to our planet and the life we know today? I know I am.
Absolutely. Let's do it.
All right. Our story begins with a massive cloud of dust and gas known as a molecular cloud.
Okay.
Now imagine something stretching 100 light years across. That's 6 million times the distance between the sun and Earth.
Whoa, that's huge.
I know, right?
Yeah.
This cloud was essentially a graveyard of dead stars, containing the very building blocks of our solar system.
Wow.
Like the ultimate recycling project, wouldn't you say?
That's a great way to put it.
And the force that brought all this scattered debris together was gravity, the architect of our cosmic neighborhood.
Gravity, it's always gravity, huh?
It is, isn't it?
Yeah.
Okay, so gravity starts pulling these particles together, and things get really interesting.
Okay.
The cloud's core heats up as particles collide, eventually reaching a point where it ignites and forms our very own sun.
I mean, it's just amazing to think about the power involved in that process.
I know, mind-boggling, isn't it?
Yeah.
And what's even more incredible is that the remaining material swirling around this newborn sun eventually formed the planets we know and love today.
Okay, so we're talking about the protoplanetary disk, right?
Exactly. Now picture this. A chaotic dance of about 20 protoplanets jostling for space around the sun.
Right.
And these weren't the planets we know today, but they're precursors.
Gotcha. Okay.
It was a turbulent time with these protoplanets constantly colliding and merging. Some grew larger while others were absorbed.
Wow.
This cosmic game of billiards is how Venus, Mercury, Mars, and of course, Earth emerged.
It's mind-blowing when you think about it, you know. Our planet emerged from this chaotic, violent beginning.
I know, right?
Yeah.
Hard to wrap your head around it.
It really is.
Speaking of Earth, let's talk about its fiery beginnings.
Oh, all right. So we're going way back.
Way back.
Oh.
Early Earth was a molten world, a fiery ball of rock and metal.
Like a giant ball of lava, basically.
Pretty much.
Wow.
As it cooled, heavier elements like iron and nickel sank towards the center, forming the core.
Okay.
But here's where it gets truly remarkable. That spinning core generated Earth's magnetic field.
Oh, the magnetosphere.
Yeah.
It's like an invisible force field.
It is.
Protecting us.
Protecting us from the sun's harmful radiation.
Right. And without it, life as we know it just wouldn't be possible.
Exactly.
It's amazing how that works, isn't it?
I know, it's so essential for us.
Yeah. And as a bonus, we get those stunning auroras at the poles.
Oh, the auroras, they're breathtaking, aren't they?
Absolutely incredible, yeah.
But the drama doesn't stop there. Earth had one more major encounter that would change its destiny forever.
Oh, okay. What happened?
A collision with a Mars-sized planet called Theia.
Wait, a whole planet?
A whole planet.
Wow, okay.
This impact was on a scale that's hard to even fathom.
Yeah.
Just imagine the energy released, the molten rock flung into space.
It's hard to believe that Earth even survived.
I know, right?
That's incredible.
And yet, from that chaos, something beautiful emerged. Our moon.
Okay, so the moon formed from that collision.
Exactly. The debris from the impact gradually coalesced, forming our celestial companion.
Huh. That's amazing.
And in the early days, the moon would have appeared much larger in the sky, slowly drifting away over billions of years.
It's fascinating how something so destructive could also create something so beautiful and essential to our planet.
I know, isn't it? But its influence goes even further than that. The impact also tilted Earth on its axis at 23.5 degrees.
Oh, and that tilt is what gives us seasons, right?
Exactly.
Wow, it's just incredible how that one event, this cosmic collision, is responsible for the cycle of life on Earth as we know it.
I know, it really makes you realize just how interconnected everything in the universe truly is.
Absolutely.
And speaking of essential ingredients, we can't forget about water.
Ah, yes, water. The lifeblood of our planet.
Right.
You know, for a long time, it was thought that Earth formed with its water already present. But recent evidence suggests a different story, that water actually arrived much later.
Later.
Yeah, around 500 million years after Earth's formation.
Wait a minute. So you're telling me Earth was a dry, barren wasteland for millions of years?
It seems that way.
How did all that water suddenly appear?
Well, that's where things get a little mysterious.
Mysterious, huh?
Yeah.
Okay.
Scientists have studied ancient zircon crystals, and their age, about 4 billion years old, tells us when water became abundant on Earth.
So we know when it happened.
Yeah, we know when it happened, but the question is, where did it come from?
So we've got this planet, right? Volcanoes, molten core, brand new moon,
Yeah,
but no water.
right.
Dry as a bone.
Yeah, like a desert planet.
And then suddenly, boom, water everywhere.
It's like, where did it come from?
It really is a cosmic magic trick, so where did it all come from?
Well, the answer might lie in those icy wanderers comets.
Comets, huh?
Yeah, you remember NASA's Deep Impact mission?
Oh, yeah, where they, like, smashed a probe right into a comet.
yeah, exactly.
Those images were incredible.
Oh, they were amazing. And what they discovered was pretty groundbreaking.
What'd they find?
Well, comets, they contain a significant amount of water ice.
Oh, wow. So that lends support to the idea that comets could have brought water to Earth.
Yeah, that they originated in the asteroid belt and then, made their way here.
So these icy travelers, just hurtling through space, smashed into Earth and delivered the water that makes life possible.
Yeah, it's pretty amazing, huh?
It's mind-boggling how something so destructive could be so essential for our planet.
It is.
But wait, how did those comets even get knocked out of the asteroid belt?
That's where Jupiter comes in.
Jupiter, the big guy.
The big guy, exactly.
What'd he do?
Well, with its immense gravity, Jupiter acts like a cosmic billiards player, disrupting the orbits of comets in the asteroid belt.
So Jupiter was just flinging comets around.
Pretty much, yeah, like a cosmic slingshot.
Wow.
And some of those comets, knocked off course, were pulled in by Earth's gravity.
So it was a bombardment of icy comets, each one delivering a bit more water to our planet.
Exactly.
It's a chain reaction of cosmic proportions. We've got a giant dust cloud, a fiery birth, a planet-sized collision, a tilted axis, and then bam, comets delivering water.
It's like a recipe for a planet, isn't it?
It's almost too incredible to believe, yet here we are, sitting on a planet teeming with life, all thanks to these incredible events.
It really highlights how everything in the universe is interconnected.
It really does.
One event leads to another, and ultimately shapes the world we know.
Exactly. But while our Hindi source explains the origins of Earth and its water, it leaves out one crucial element.
Oh, what's that?
Oxygen.
Oh, right. Oxygen. I mean, we need that stuff.
We kind of do.
Yeah.
So Earth had water, a stable axis, and a protective magnetic field, but no oxygen.
Well, not the kind of oxygen we breathe today.
So what was the atmosphere like back then?
Pretty toxic, mostly carbon dioxide, methane, nitrogen. Not very pleasant.
Not at all. So how did this toxic cocktail transform into the breathable air we depend on?
Well, that's where these tiny but mighty organisms come in. Cyanobacteria?
Cyanobacteria.
Yeah, also known as blue-green algae.
Okay.
They possess a remarkable ability.
What's that?
Photosynthesis.
Oh, like plants.
Exactly. They were like the ancestors of plants.
Cool.
They harness the power of sunlight to split water molecules and release oxygen.
Wow, so these tiny bacteria were pumping out oxygen as they made energy? That's incredible. But wait, if this was happening billions of years ago, why didn't oxygen levels in the atmosphere rise immediately?
Well, initially, the oxygen produced by cyanobacteria reacted with other elements in the environment, particularly iron.
So it's like a giant rusting process.
Exactly, on a planetary scale.
Wow, so the oxygen was being absorbed by the rocks and minerals. It wasn't building up in the atmosphere right away.
Yeah, it took hundreds of millions of years for those reactions to run their course.
So only then did oxygen start to build up in the atmosphere.
Exactly. It was a slow, gradual process over eons.
And all thanks to those tiny, hardworking cyanobacteria.
They were the unsung heroes of our planet.
I know. It's amazing how something so small could have such a profound impact on the entire planet.
It really shows you the interconnectedness of life in our planet.
Absolutely. These tiny organisms completely changed the course of Earth's history, paving the way for us.
And it underscores the importance of understanding and protecting our planet's ecosystems.
Absolutely. Even the smallest organisms can play a crucial role.
Exactly.
We started this deep dive with a Hindi source that focused on the formation of Earth and the arrival of water.
Right.
And through our own exploration, we've uncovered an even richer story, one that connects those cosmic events of billions of years ago to the very air we breathe today.
It's been quite a journey.
It has.
And it shows that learning is a continuous process.
Always more to learn.
Always.
Those cyanobacteria, they really were the unsung heroes, weren't they?
They really were. working away for millions of years so we could be here.
Makes you wonder what other tiny things have had a huge impact on our planet.
I know, right? And that's what I love about science. You just never know where the next big discovery will come from.
Yeah, like we started with this Hindi text about Earth's formation and the arrival of water. And now we're talking about the air we breathe.
It's all connected.
It is, isn't it? We've come a long way on this deep dive.
We have. But, even though we've answered some big questions today,
Yeah.
we've also uncovered even more mysteries.
That's true. There's always something new to discover.
Exactly. And who knows, maybe our listeners will be the ones to make those discoveries.
Hey, that's a great point. To our amazing listener out there, we hope you enjoyed this deep dive into the origins of Earth.
Yeah, it's been a wild ride.
It has. Keep exploring, keep asking questions, and most importantly, never stop learning.
The universe is full of wonders just waiting to be discovered.
Absolutely. And we'll be back next time with another deep dive into a fascinating topic. Until then, keep looking up.